Showing that they're the same. That's the point. Okay, so we're working on chapter 4. This is 4.1. So we found the y-intercept by plugging in 0 for x. We find the vertex by plugging in, by doing negative b over 2a. So we have 8 over 2, which is 4. So my x value of my vertex is 4. This means the axis of symmetry's equation, well, that's the exact same thing. It's going to be x equals 4. And then what else did it ask us to do? Make a table of values that includes the vertex. So I'm going to make a table of values over here. Cool. Yes. So how did you find it? 4, so plug in 4 for my value. So 4 squared minus 8 times 4 plus 15. You get 16 minus 32 is negative 16. Negative 16 plus 15 is negative 1. So I have my vertex is at 4 comma negative 1. And notice the scale goes by 2 vertically. It goes by 2. Pull that up so you can see it a little better. Okay, my axis symmetry. So you don't necessarily have to draw this. Last year I made them draw it. This year we spoke about it because I wasn't sure if it really helps people. So the axis symmetry, the left of this is going to be the same as the right half. So if I plug in, we could go by 2s and that would be fine. Because, oh my gosh, why is it so slow? No. Okay, let's go 2 and 0, 6 and 8. Because we already know the value for x equals 0, it's 15. So that means this value down here is going to be 15 as well, because the x is an equal space away from 4. So I'll have the same y value. So at 0, I have a y value of 15. And at 8, I have a y value of 15. Because what I do to one side of the axis symmetry, I do to the other side. Which is another way to really intuitively think about it. Okay, if I plug in 2, right, let's find f of 2. No, it's not necessary, but I'm trying to make a point, axis of symmetry. Last year I made them draw it, this year I'm not making you draw it. What I do to one side, I do the other. So at 2 I have a value of 3, and at 6 I have a value of 3. So my right half, right of the axis symmetry, looks just like the left of the axis symmetry. It's mirrored across. Okay, and that's all it wanted us to do. How many solutions do we have? 2, because solutions, that word means the same thing as roots. Solutions, the same thing as roots, which is the same thing as zeros, right? Same thing as asking for the x-intercepts. All of these words mean the same. So I'm telling you this because you shouldn't come up to me and ask, what does it mean, solutions? It's asking for the x-intercepts. Where do you cross the x-axis? And when you're factoring, the solutions are what you set to 0. You factor and set them equal to 0. Okay, do we feel comfortable? Do you want to try another one, or do you want to keep going? Keep going? Another. Okay. Wasn't sure if this might keep going. Cool. Let's do another. Let's do number 2. I'll give you 20 seconds or so. Try it, right? It's the same process what we just did. You find the y-intercept. You find the x-axis. The x of your vertex. Make a chart. Graph. Try it yourself. It does, because keep in mind a negative is in front of x squared. No, because it's negative x squared. You have to square before you multiply by negative 1. Order of operations. You have to square your x value before you multiply by negative 1. Okay, so Let's start. Oh no, come on. Okay, our y-intercept. Is that 0, 12? We good about that one? Thanks, so you just plug in 0 for x. Okay. So your vertex, the x value should be -2. This is the same as your axis of symmetry. So I could draw a vertical dashed line at like x equals -2, and the left side of the graph is going to be the same as the right half. That's why it's an axis of symmetry, because the left and right of it are the same mirror images of each other. Okay. All right, you always put your axis of symmetry right in the middle. Right here, we're going to find 5 points. You always have it right in the middle. So I'm going to plug in -2. So you have to do order of operations. You must square your -2 before you can multiply by -1 in front of it. All right, so it's a negative of 4 plus 8 plus 12. So then that's going to be 16. So that's a little tricky. So after you find your vertex, you're like, okay, you either do the 2 numbers above it or the 2 numbers below it, and then you're going to use axis of symmetry. Well, we already know the y-intercept. We found it. So we put in 12 for my y when x equals 0. And then using symmetry, I know the bottom one's going to be 12. So you just have to find the y value when x equals -1. Okay, I'll pause here. Do you have questions about this one? I'm going to try not to be too fast. You can go ahead and graph it. Keep in mind the y-axis scale is by 2s. That's roughly what our parabola will look like. Okay, so how many solutions do we have? 2, right? Because we crossed the x-axis twice. There's 2 solutions. Okay, so we're not going to do number 3. We're going to do number 4 and number 6. We're going to do 4 and number 6. Does anyone need me to leave this up for a little bit longer? Good. So try number 4. See if you can get it by yourself. Try number 4. Looking if it has a min or max, and then we find the min or max value. Try number 4. Okay. So once you're done, you can check your solution on the board. So we look at the a value, the coefficient in front of x squared. Right? There's not a coefficient there, but it's not negative, so we know it's positive. And if you're happy, you're smiling, and so that literally tells you what your parabola will look like. So it goes down to a minimum and then back up. And then to find the minimum, you find the x of your vertex, because it tells you which x value you will have a minimum at. It's kind of like in physics, like we know at what time we'll have a maximum height, right? X here is our time. But it doesn't tell me what the maximum height is. The maximum or minimum is the actual y value. So you have to find the x of your vertex, and the y of your vertex is always your min or max. So once we find the x, you plug in and you'll find the y value. It's always the y of your vertex. Okay. Try out number 6. So I'll give you, yep.
So the y, like, the y is always
The min or max. The y of your vertex is always your min or max. So I want you to try number 6. Try number 6. Did we find should be a min or max? Max, right, because there's a negative coefficient in front of it, number 6. So it's going to have a maximum value, and then you just have to find the vertex, right? Because the y of your vertex will be your maximum. So I'll leave this work up here. It's kind of hard to see, it's really small. So 98. 14 times 7? Yeah. So she found the x of the vertex is 7. Plugging in, we find the y. Cool. Awesome. Okay, do we need a little more time? Do we want to go over another problem like this? This is negative in front, it'd be max. Positive in front, it'd be a min. You just have to find the y value of your vertex. Okay. Okay. We're doing 1, 2, and 3. So, without saying it out loud, think how many solutions are there for number 1? Okay, I'll count 3, 1, 2, 3, 2. Okay, and then if I ask how many solutions there are, there's 2 solutions. If I ask what are the solutions, what are they? What are they here? Do we know? Yeah, negative 1, 0, and 1, 0. So how many versus what are? Just have to read the directions. So, turn to the person next to you and let's discuss number 2. How many solutions are there? Good. We hear none. No solution. There's no real solutions. No real solutions. And now that we found out about imaginary numbers, no real solution. Now that we know about imaginary numbers, technically there's 2 imaginary solutions to this equation. Because if you plug into the quadratic formula, you would find a negative under the radical, so it would give you an I in your solution. So both solutions we find with quadratic equation would give us I's, which are not real solutions. So no real solutions. And then number 3, there's 2 solutions. That's how many they are. And if I actually want them, solutions, they would be 1, 0 and 2, 0. Cool. So that's all I want to do on number 2 on the second page. Yeah. So now to our main event. 4, 5, and 6, not the part with if the exact root can't be found. Consecutive integers, I think that's probably one of the dumbest things I taught you this semester, right behind like properties, right? Because I just think about okay, how many times have I done that? It's more estimating. You're like, oh yeah, okay, it's between -1 and 0. We estimate all the time. I'm trying to work in estimation and like intuition building into like normal. Like, okay, what do you guys think it should be? If I have negative x squared, blah, 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 what do you think it should look like? Oh, okay, down because of negative. So I'm trying to like build that into you anyway. I'm not gonna like, the way I'm gonna ask the parabola question, I wanna be efficient. I wanna have as least number of problems as possible. So I'll ask you like all the things about one single parabola, you know? I'm not gonna ask you like, oh, graph this one, now do this. Like, no. Graph the one, find me the y-intercept, the x-axis, the axis symmetry, how many solutions, what are the solutions, all in one problem. Just like the first page of your chapter 4 test. Okay, so this is the part that we struggle with. It is what it is. I'm just going to erase this all. You know we're doing 1 through 9. That's the goal, 1 through 9. It is 2:54. We have 20 minutes. Whew. Okay, yeah, you probably want another piece of paper because there's no room to do all these problems. Yeah, and my approach is this is the free throw of the Algebra 2 world right now. Factoring. Some of these, like, in order to get better, you gotta practice, and you know I'm gonna foul you a couple times, so you're gonna have to factor. You gotta factor. Just like the chapter 4 test, I'm gonna ask you those 3 questions again. Solve by factoring, solve by cleaning the square, solve by quadratic equation. Those 3 exactly on the test. Yep. So we gotta know how to do them. So the order we go through. So I'm like, hey, solve and factor. First, look. Is there a common factor in all of my terms? No. Can you go to the bathroom? No. You have a question? Yes, yes. Okay, Jesse. Negative 6 and 2. Ooh, okay. Ooh, that's not what I want. Negative 6 and 2. So I have x minus 6 and x plus 2 because together they multiply negative 12. They add to negative 4 because they add to the middle, multiply to the end. What? Yes? Ah, that's what, yeah.
And then do we have to show our work when we're getting what x is?
So, like, this right here, this is good enough. Because that shows me, like, you factored, you know? So on a problem like this is designed to be a simple, fast question, but in order to have it that way, we gotta just, like, practice some quick factoring.
So wait, before we can like do like the things with the parentheses, we have to check if like there's a greatest common factor.
Yes.
What if there is a greatest common factor?
Then you pull it out. Then you pull it out, and then you try to factor what's left.
And what if you like would you still like could you not pull it out and just
You should pull it out. Okay, so try number 2. I'm gonna make that a little smaller for you. Try number 2. So first, see if there's a greatest common factor. Then, is it one of our special cases? Difference of squares or perfect square trinomial? Then try factoring, and if nothing else works, then quadratic formula.
Wait, on the test, on the chapter 4 test, to practice, you gave us like a bunch of these kind of ones, like 1, 2, 3, 4, whatever, like these. But on the test, they all had coefficients in front of the x.
No, they didn't.
They did, because I have like the test and like I just like both of them, or like 2 out of like the 3 factoring ones you gave us coefficients, but we'll be doing that like.
So one of them was greatest common factor. I was testing on greatest common factor and difference of squares. Instead of having 2 problems, I had 1. That was the 4x squared minus 36x, or whatever.
No, because I'm looking at like the part where you asked us to factor, like on the chapter 4 test.
I will come over and I will show you. I'll come over. Yeah, okay.
No, I'm just wondering, because on the problem is supposed to drop the 4 and you just that and it's a 4. Yeah, this is a factor, very small factor, so it's not actually a coefficient plot. This one is a coefficient plot, so that one is a coefficient plot. Then this is not. Okay, But
this one, which one?
like, are we gonna be practicing like some better? Because I don't know, I just feel like I wasn't prepped for that because most of the ones that
I see. You got like -8.
Oh, yeah.
Can you do those?
I thought I just wasn't prepped for that.
Oh, no.
Because most of the ones that we practiced on.
Are you here today with other publishers over the wall?
Yeah.
Just look what they are.
Can we do those?
We are, if you look, like 13 below and stuff. So we're getting to it. We're just going through step by step. So I hear you, you feel prepared. I did go through some of them. I went through the exact one that was on the test before. Number 2, x squared minus 16x plus 64. So there's 2 ways to solve it.
Yeah.
You either could say add to negative 16, multiply to 64. Or you could say, wait, is this a perfect square trinomial? So I could take negative 16, divide by 2, which is negative 8. And then if I squared negative 8, it's 64.
I did not do that.
So we're factoring by seeing that it's a perfect square trinomial. So we recognize it's a perfect square trinomial, which means we have 2 of the exact same factors.
So we can do one number.
Exactly. So it's just going to be x equals 8. Positive 8, because you set each factor equal to 0. X minus 8 equals 0.
What if you were to do it like a plus?
Plus 8, so we see x equals 8. What?
But if you were to do it in like the way that it was like.
What adds to...
Y plus y equals 16.
Yes.
Plus 64, wouldn't that be negative 8?
That is negative 8 and negative 8. And we only need it to write it once to write the solution. Only have to write it once. All right, number 3. X squared minus 20x plus 100. Perfect square trinomial, because half of negative 20 is negative 10, and if you square negative 10, it's 100. So x minus 10 times x minus 10 equals 0, so you see x equals 10. Awesome. We're going through all of 1 through 9. So number 4, do you want me to go back to number 3? Are we okay? Number 4, I want you to try this out. Adds to negative 6, multiplies to 8. Hopefully these are easy and we can go through them relatively at a good pace. Perfect. Negative 4 and negative 2. Because whenever you are multiplying to a positive and adding to a negative, both numbers have to be negative. So you see, when I solve, I get x equals 4 and 2. Because I'm setting each factor equal to 0. I don't have the room to show every step. Set each factor equals 0. X minus 4 equals 0. Add 4 on both sides. X equals 4. Okay, try number 5. If you haven't already, try number 5. Yeah. I don't know what these peeps are doing. If you want, we can do the I will be successful. I will be successful at finals. Yeah, heard that? I've heard that 4 times. Okay, cool. No, if you want, we can. I did it in my last class, so I did it in A period intermediate. Sure, we can do affirmations tomorrow. That would be great. Cool. Number six. Here we go. You okay? Just look like you're flip a table. Okay. Think about. Okay. Don't say it out loud. Think about it. Add 2, -9 multiplied 14. And go. -7, -2. Okay, cool. So we see x equals 7 and 2. Try number 7 if you haven't already. Number 7, number 8. Yes, but I want you try it. Can I move on? Okay. Number 7. So the first thing we always look for is greatest common factor. Ah, yes, greatest common factor. There's an x in both terms. So x times x minus 4. Set each factor equal to 0. Let's pull out a factor of x in both of these terms. X squared and -4x both have x as a factor. If you pull it out, you're left with x minus 4. It's number 7.
Could you also just do like x minus 4 x plus 4
I mean, technically x minus 0. But the x minus 0 is the same thing as x. So you should just leave it as x. Because it's a common factor.
Would you have to say x equals 0 and 4 or x?
X equals 0 and x equals 4. Correct.
We couldn't just do x plus 0, x minus 4.
No, you need to have x times x minus 4. You have to pull out the greatest common factor. Okay, so number 8, the first thing we must do is what? Number 8, first thing we must do is move everything to the same side. We must move everything to the same side. Now I have 7x squared minus 4x, because it has to be set equal to 0 before we can factor and solve. Only can solve if we have 0 on one side, everything on the other. Now that I have this, there is a common factor. X. Pull out an x. And I have 7x minus 4. Set each factor equal to 0.
No, but if x was going to 7x minus 4, then it would be 7.
Okay. So we have 7x squared minus 4x. Are you good at this part?
Yeah.
Okay, because I subtracted 4x on both sides to get everything on one side equals to 0 on the other. Both of these have an x in them, so I factor it out. So 7x times what is x? I'm sorry, x times what is 7?
And stuff, but where does like the 7x to the second go?
Right here, 7x. Because if I distribute this back, x times 7x is 7x squared. X times -4 is -4.
Yeah, but
so we're
when
using
it's
the distributive
7x minus 4 equals 0, where
Yeah.
did the x go?
What? X is right here? 7x
No.
minus 4?
The x that
You
was
set each
in
side
front.
equal to 0.
X times 7x minus 4? So I set x equal to 0 and I set 7x minus 4 equal to 0. Each factor I set equal to 0.
So then it would just be 7 times 0 that's equal to 0.
No, I set this whole term equal to 0 and solve it. set each factor equal to 0, and then solve. So number 9, what's the actual very, very first thing we must do? Get everything on the same side. Gotta get everything on the same side. And then we can go through and see if we have a greatest common factor and factoring and stuff like that. Okay, so I'm gonna scroll out a little bit. Try to leave it so it's still kind of in view. So the very first thing I must do is move this to the other side. So now I have x squared minus 10x plus 25 equals 0. Why is this like, can you guys know, it's so weird. My screen is like vibrating. It's giving me a headache. Hold on, I want to see if I can show you. Okay. Can you like see the numbers moving? No, I don't either, and it's giving me a headache. Okay, so I moved everything on the same side. Now I can try to factor. All right, there's no greatest common factor. Is this a perfect square trinomial? Yeah, okay, so it's one of our special cases we recognize right away. If not, no worries. What adds to negative 10 multiplies 25? Negative 5, negative 5. So then we see x equals 5 is my solution. Amazing. So we still have like 6 minutes of class, and this is where I got with my other class, my other period. We stopped at number 9. So what we can do is, why don't we go to one of the harder ones? Like, we can do number 13. That would be a great problem, because number 10, 11, and 12, I have faith that you could do yourself. I mean, you could do 13 yourself, but I mean, we could do it together. Yeah. Well, so number 13, so this is, I think what Isabel was talking about was like, I put coefficients other than 1, JK. I only did that so you could pull out a greatest common factor and then factor like normal. So the one she was talking about was the one that was like, 4x squared minus 36 equals 0. Well, if you pull out a 4, I think it was 4x cubed minus 36x. If you pull out a 4x, you're left with x squared minus 9. So that was testing you on pulling out a greatest common factor and then having a difference of squares. So technically, I mean, yeah, it was a coefficient other than 1, but it was to make you go through the order properly. Okay, so number 13, what's the first thing we should do? Everything's on the same side, so we should check if it has a greatest common factor, which it does. It does. It has 5. And now we don't have to worry about a coefficient other than 1 because the 5 is now no longer there. Yep. So what adds to negative 7 multiplies to 12? Negative 4, negative 3. So to fully factor, I have 5 times x minus 4 times x minus 3 equals 0. This is the fully factored form, but now I want the solution, so I set each factor equal to 0. 2. Because if I set 5 equals 0, that's not true. It doesn't give me a solution. So x equals 4 and 3.
Is it David Marcus who's in charge of the ACD?
Yes.
I sent him an email.
You are sending him an email?
Because it's like every single day, like everyone is freezing and it's
Just bring a jacket.
No, it's horrible for the environment too. It's so bad
Okay, I am an environmentalist, and you're preaching to the choir here. So, all right. So tomorrow we're gonna do more review of chapter 4.